two reasons that these are combined. One is that there are very, very few notes for 20F.2. It's basically one slide and be like, oh hey, here are some other symbols. So there's no real examples that pertain to 20F.2 that are any different from 20F.1. And I have training for the next 2 days. So there's going to be a lot of teachers out, so just be extra good, because I bet you the teachers are going to be cranky because they're going to be subbing for each other and everything. There's just a lot of teachers on this training. So I will not be back until Monday. So tomorrow will be a work day for these assignments. And then Friday will still be 20F.3, but it's a very small change. So I just made a calculator assignment for that. So you'll be able to use the calculator. And then if you have any assignments not done, it would be a great idea to just make sure everything is finished, right? Because there's no more notes or anything. Does this make sense so far?
She just said a work day.
I don't think, these questions take a little bit longer, as you will see. There's more work to show, but Fridays is probably not going to take you a whole hour, because you're going to use calculators on it, so then you'll have extra time. All right, so 20F is variance and standard deviation. The subheading for F2 is sampling from a population, but I'll have that subheading again. So if you just write variance and standard deviation, we also don't have a stat box today, but we'll be all right. These formulas look scary, but we're going to break them down so that they are not scary. And the concepts are a little bit out there, but we'll be all right. First off is something called variance, and let me zoom her in a bit here. So variance is given by this formula here, S sub n squared equals the sum of your x values minus x bar squared, all divided by n. So what this is it has some symbols we've already talked about, like what does the x bar stand for? The mean. So we know that my smartboard got misaligned somehow in between here. So we know that this is the mean. What about the n? Do you remember what n is? We've had that earlier this chapter. Yeah, it's the number of data. So like if you took a sample of 100 students at Case High School, n would be 100. So what we are actually measuring is how far every single data is from the average. So this x minus x bar squared is a measure of how far x sub I is just an individual data point from x bar, that mean. Now we square it so that we don't have some negative values. So that's one kind of issue there, is we have to square it so we don't have some negative values. The square makes sure that each term is in the sum is positive. Sorry, that was where you're kind of goofy right there. So we have got to square it so it's positive. Now, what we do then is we end up taking every data point, subtracting the mean from it, squaring it, and then we add them all up to kind of see how far they are, how far away or how close they are to the mean. Now, when we divide them by the total number, when we divide by n, that actually gives us the average. So it looks complicated, but it actually isn't that crazy. You know how to calculate the mean, you know how to subtract, you know how to square, you know how to divide. Like, you know how to do all of these pieces. It just looks crazy. like we're all done. Not right. I know there's a lot of stuff on there. So I need to talk slower. I need to like talk and wait. One other point about variance is that it's not super useful actually. What we're going to talk about next is used a lot, and I was having a discussion with Ms. Ewan about the difference between variance and standard deviation, and she said that you'll get more into why it's important when we hit chapter 24, but that would be something you guys are going to work on next year with Ms. Ewan. So we're doing 20, 21, and 22. So when you get to chapter 24, you'll talk about normal distribution and stuff, and so a lot of this stuff will kind of become more clear, but we have to get some of the basics out of the way now. Someone grab that for me, please. All right, so standard deviation now is almost the exact same formula, but you will see it's square rooted. And so standard deviation is S sub n. So S sub n stands for standard deviation. And it's the same formula except for we square root it. So it's still the sum of all of the squares of our data points minus the average divided by the total. So we square root all of that. We square root the variance to get the standard deviation. And what this does is it measures how spread out the data is from the mean. So once we take that square root, it tells us, okay, how far are values from the average of this data set? Now, this is where I'm saying I should stop. Okay, so then if we calculate the standard deviation and it turns out to be 0, that would mean that all of the values are exactly the same, that everyone got the exact same score, which we know doesn't really happen a lot, but that's what that would mean. The reason behind the square root, because it's the exact same formula as variance besides the square root, is that when we did the x minus x bar squared, that changed our units to being squared, so we have to square root everything to correct the units so that we stay in the same units. So like if we are talking about height, the standard deviation is also in height because that's the difference in height from the mean. We also considered standard deviation to be non-resistant because it depends on the mean. We have a few people that are in psychology, right? Is that more my second and my eighth hour? Well, if you do have any interest in psychology, standard deviation, or any kind of research that you end up looking at, standard deviation will definitely pop up. So even if you're not taking like SL2 next year, in your future studies, you'll probably run across standard deviation. So we have this little video that we found that sort of also explains standard deviation, so we thought it would be nice if we watched that. It is slightly geared towards psychology. I think the video is like 4 psychology stars, like how to be a psychology star, but it still sort of simplifies some of this explanation. I don't think I've ever played a video from a Prezi, so here we go. Oh wait. I forgot about speakers. So that's what I was talking about you get to later, that normal distribution curve. So you expect the scores to mostly be in the middle around the average. Okay, did you guys catch that? Oh my gosh, too slow here. All right. All right, here we go. So do you guys catch that? So if that standard deviation is a small number, that means that most students were close to average, whatever the average is. If that average is 75% or 80%, and most students were around that 80% range, and there were very few students that got low scores or high scores. So it's closer to average. Are we good? So then if we have a big one, then we're really spread out, and there might be a lot of high scores and a lot of low scores, but not as many scores in the middle. So like when I come back and say, oh, you guys got A's or F's, it's a situation like this. Oh, being let's call it a math star, not a psychology star. Okay. I know that video kind of was at like a lower level, but were those pictures helpful to kind of understand like how we can use this? So it tells us if the scores are far away or close. And again, you will see that in other places in, your future. All right, here we got an example. So we're going to find the standard deviation, and to do that, we will have to find the mean. So we've got a few different things on our tables. Now, sometimes you'll have a frequency list. Sometimes you might just have individual values, so don't freak out about that. But we took all of our scores, put them in the X spot. We took a frequency. Now, we have this F times X column, which we've had before. Now, we need this so that we can find the mean. So remember, we'll just multiply these to get it. So I'm going to give you guys a second to get that information in the table. And then we'll start going about how we can calculate these. Man, I just want it a little bit zoomed in. There we go. So everyone got the first two columns? Because I want to realign my board before I keep filling in. So once you have those first two columns, start filling in the F times X. We've done that before. So it's fill in the F times X. And then remember that that is, when we add those all up, that's like the sum of all of our values. So then add them up in the very bottom column. Or bottom row, I don't know why I said column. So F times X. Now we add these all up, we should get 600. That's the sum. Now that was what we used for finding our mean. Now remember our mean, that's X bar, was the sum over the total amount of values. Well, I have to add up my frequency column to get the total amount of values. So when I add these all up, I get 20. So that is n. So I end up with my mean then being 600 divided by 20. So that is 30. So the average score on this test is 30. You have to have the average to move forward. That's why we need that fx column. Are we ready for the next column, or are we not quite ready yet? So for our standard deviation, I'm just going to write down the formula for the standard deviation. It's the square root. We have the sum of the x minus x bar squared, all divided by the total. I think it's supposed to say xi, but I didn't add that part on there. Just kind of simplified it. So we have to add those all up. So that's why we have all these other columns, because first we have to do all of our subtractions, then we have to square all of our subtractions, and we've got an extra step on this one because we do have the frequency. So when we do this x minus x bar, I'm taking this x minus 30 because that's our x bar, that's our mean. So 10 minus 30 is negative 20. 20 minus 30 is negative 10. 30 minus 30 is 0. 40 minus 30 is 10. And 50 minus 30 is 20. So I just took these numbers minus the mean. After that, for our next column, we just square all of these numbers. So negative 20 squared is 400, about 100, 0, 100, and 400. So we just take those numbers and you square them. Keep in mind, like if you rely heavily on your calculator, depending on how you enter it, if you accidentally enter negative 20 squared, it might tell you negative 400. So remember that you are smarter than your calculator. Now, sometimes when you don't have a frequency, I don't think you're going to have any that actually have a frequency until your F assignments, but you might not have this last step. If you don't have a frequency, then you end up adding these numbers and it goes right on top. Since we do have a frequency, this is actually the addition of all of these numbers, so I have to multiply my x times x bar squared times the frequency. So 2 times 400 is 800. We just have to do that because this one has got a frequency. Again, sometimes you don't have that column, so it's a little bit less steps. And then we do want to add these all up because this is our sum that we have to use for our formula. So when we add those all up, we get 2,400. So then we have to take the 2,400 divided by the total number of values, which is 20, and then square root. So then we end up with the square root of 120. So our standard deviation ends up being 10.95, or you could say about a standard deviation of about 11. So I know there's a lot of different parts, but again, it's all, basic skills we know how to do with multiplying, dividing, adding, subtracting, square rooting, squaring. Is there any piece that we're confused about? Remember, I'm going to be gone for 2 days. Yes.
So if we didn't have where would we add them at?
These ones. We had to take account of the frequency that there were 2 values that were 10, 4 values that were 20, and so on. So you might have a column without that. I was just looking at it earlier today and noticing that not all of them had frequencies with it. Like if you're calculating like basketball scores, like we talked about basketball squads earlier, I mean you're not going to have like 3 games that all had 40 points, so you might not have that frequency part of it, but that it just means it's less work. So for tomorrow's assignment, I do want you to practice doing these by hand and making your table and using the formula. When you get to Friday, it's technically 10F, which I wrote a few notes on it for you, but there really isn't much notes. Do you guys remember when we had the intervals, we had to use the midpoint in order to calculate the average? That was from 20B3. So like if you forget the midpoint, you can go back to that section and look, but that's the only thing that's different. And I want you guys to use your calculator on it. So I'm going to give you a little calculator instructions and just have you do that assignment. So the 20B3 will be really quick with the calculator. But I want you to practice by hand tomorrow. So are there any questions on all of this by hand? Okay. So the next slide is just a few notes on B2, which I just kind of want to zoom in a little bit here. So this is sampling from a population. I know we already talked about that when you are finding the mean of a sample, you use X bar. When you're finding the mean of a population, you guys use mu. Remember we talked about that last week? Well, there's 2 different symbols for standard deviation as well. For variance and standard deviation, it's S sub n when you have a sample, but it's this symbol that I think is called rho. I keep meaning to look it up so that I have it right. But that's just it. As it turns out, calculating the standard deviation is exactly the same. Like nothing changes. It's just that the symbols change. And that's what it says here as a little wrap up. When you use a sample size, you use X bar instead of mu, and you would use S sub n instead of rho. Alright guys, I just did some investigative research. It's actually not called rho. What it is, it's a lowercase sigma, and I don't really want to call it sigma because we already have sigma for the E. But it's a lowercase sigma. That's what it is. I thought it was rho. Rho is looks like a lowercase p, so they kind of look similar, and I get my p's and d's confused anyways. So, I don't know. Let's just call it standard deviation, right? So this symbol for standard deviation, lowercase sigma. Okay. This is absolutely it for the notes from F1 and F2. Are there any questions? Oh, sorry, I mean, screwing up the name of that. I don't know why I thought it was row. I just really did. I didn't even check because I was pretty sure. Alright, so then here is your assignment from F1 and F2. You've got plenty of time to get started. Like tomorrow, there's just going to be a daily challenge, and then you're going to have time to work on both of these. So if you complete them both, I highly recommend working on any unfinished assignments. I'm going to leave the substitute a list of people that don't have everything in, so they can pester you. And then on Friday, like I said, you'll get a little calculator instruction sheet, and then you'll get kind of like the B2 or the B2 calculator where I wrote some like tips on the worksheet, but just had you record your answers on the worksheet. So you'll be doing that on Friday from F3, but using the calculator, you're gonna get finished with this stuff in a snap. And then we'll come back Monday, Tuesday review, Wednesday test. So keep that in mind. I'm going to highlight it for you. Yep, it'll be right there.